All right. Okay, today we're going to be focusing on chapter 2, and chapter 2 covers basically the whole idea of how to design a program, the basic things that you need to design your own program. Then we're going to talk a little bit about different variable types and what those are, as well as data types. And we're going to talk about how to document and design your own first program. Okay, let's begin. So whenever we design our first program, the first step is not actually writing the code. And there comes a lot of decision making prior to designing your own program and prior to writing the actual code. So the things that help us to do so are flowcharts and pseudocode. And flowcharts, just think of it as a diagram of how your code should work, how things should run, and stuff like that. And pseudocode, what we call pseudocode, is just fake code. It's basically code written in plain English. So anybody who can look at your code, anybody who will look at your code, even if they don't have any prior knowledge of coding, they will be able to understand what you're trying to do in your program. So that's the first step. We are going to design some flowcharts and write some pseudocode. After that, we write our code. That's the next step. After that, we check for any syntax errors. And what syntax errors are is basically just typos. Just think of them as typos. If you misspelled a word, if you put a comma somewhere where the comma shouldn't have been, that's what syntax errors are. Then after that, we execute our code and check if there are any logic errors. And the logic errors are actually those errors about how your code runs. So if your program is doing something that it's not supposed to do, that's you probably have a logic error somewhere in your code. So we check for those. And after that, if there are any logic errors, we are doing the process of debugging. And debugging is just fixing those errors, just making sure that your program runs and does exactly what it's supposed to do. Moving on, we have, so this whole class is just basically going to focus on pseudocode and flowcharts, as well as getting you to know the vocabulary of coding and scripting, just the basic vocabulary of the IT world. So after this class, you should be familiar with the basic things. You should be able to write your own program, to design your own program, and just have a general idea of how the coding works behind the scenes. And obviously, as I mentioned before, the design is the foundation of your program. So basically, how well you're going to design your program, that's going to determine how well it's going to run. And this is the program development cycle. Everything that I covered on this slide, just put in a little diagram here for you to see. So with the steps, so first we design the program, then we move on to writing our code, then we correct any typos, then we test our code and see if it's executable, and then we debug the code, just fix any errors that your code has. There are two steps that come to when we're designing our program. So the first one, we actually have to understand what our program needs to do. Because when you graduate from this program and you go into the IT world, you're going to be working with customers. You're going to be working for other people. So other people will come in and tell you what they need, what they want their program to do. And it's your job to understand what exactly is needed from the customer, what customer is trying to tell you. Because from my personal experience, sometimes the customers can be vague, sometimes they don't know what they need, they just want a program, right? And it's your job to make sure that you check all the boxes and you get the customer what they actually want. Then after that, the second step is you have to determine what steps you need to take to write that actual program. And what we call that creating an algorithm. And an algorithm is just, think of it as step-by-step instructions, step-by-step directions to solve whatever problem is in front of you. After that, after you created that algorithm, you will have to use flowcharts and or pseudocode to solve that program. Let's focus on pseudocode. As I mentioned before, pseudocode, just think of it as fake code written in plain English, basically. Plain English with some algebraic signs. As you can see here, we have a equal sign, a multiplication sign, dollar sign. So just plain English with some numbers or maybe some operators. So there are no syntax rules in pseudocode. You cannot make any errors when you're writing pseudocode. However, the pseudocode really helps you to translate your actual code, your pseudocode to actual code. So in this case, we have a little example right here. We have a program that is supposed to display the number of hours. So we're going to ask the user to enter the number of hours that they worked. They will then input those hours. So they will use the keyboard, type some number, how many hours they worked. After that, we're going to ask them to display how much money they're getting paid for an hour. And then they're going to provide us with that number. And after that, we make some calculations and we're just going to display how much money they're going to earn for the number of hours that they work. So this is all that this program does. And if you look at it, you could probably make sense. You could probably understand what this program is doing, right? Because it's written in plain English, it's quite simple to follow. All right, so moving on to flowcharts. Flowcharts are a little bit different. Flowcharts are require a little bit of knowledge, and I'm gonna teach you that right now. So flowcharts have basically three main shapes that you need to be familiar with. So the first shape is used for just the start of your program and the end of your program. So if you see an oval shape, as you can see here, we have a start and we have the end. So oval, just the start of your program and the end of your program. Then if you see a parallelogram, that means that we're either displaying something to the user on their screen or we are asking the user to input something for us, to use their keyboard and give us some sort of input. And rectangle is used for any internal processes that are happening inside of your computer. So any calculations, any assignment statements, that's what we use the rectangle for. And let's look at our flowchart right here, the example that we have. So we have an oval that says start. Then we have a output, right? Because we see display. If you see display, that means that we're displaying something on the screen, which is the word for output. Then we're displaying something right here. Then we're asking the user to input some hours, and input again, look right here, input is a parallelogram right here. Then again, we're displaying, enter the employee's hourly pay rate. Then the user will input that number for us. And right here, you see a rectangle. Right here's a rectangle, and that rectangle is the internal process. So this is the calculation that's happening inside of your computer. The user does not see it. That's why it is in a rectangle. And you're welcome to stop me anytime if you have any questions. If you're not understanding something, just tell me, Miss Sonia, stop. Tell me that one more time. I'll be glad to do so. Now, another thing that you need to be familiar with is a connector symbol. You can see them right here. If your flowchart is a little bit too long and it cannot fit on one page, we use a connector symbol. Connector symbol is just a small circle with a letter or a number. It doesn't matter, just as long as these two match, this one and this one right here, as long as they match, that just shows you that this is all right here, this is all one thing. And we're doing that with the help of a connector. Now, if you have, if your flowchart needs to go on a different page, it's a little bit different of a connector. It's this one, this weird looking house shape. However, you have to specify where, from which page or to which page you're going. So in this case, we're specifying that the continuation is on page 2. And in this case, we're specifying that this flowchart came from page 1. So nothing too complicated here. Now let's focus on output, input, and variables. Now, as I mentioned before, output is what we're displaying to the user. So what the customer will see, that's called output. And input, it's something that the user gives us. So any data that a program will receive from the user, that's what is called input. Now, variables, very important term for you to know. You'll see it a lot in coding. Variables, think of it as just like storage location for any data. So obviously, if we want to work with our data that user provides us with, we need to store it somewhere, and we store it in variables. Usually, all computer programs follow these 3 steps. So you receive some sort of input, then you do something with that input, doesn't matter what, you do something with it, and then you project something on the screen for the user. So these 3 steps are usually how all the programs go. Now, let's move on. This is just a little diagram of that program that we were focusing on with the flowcharts and the pseudocode with the calculating gross pay. So as you can see here, we have input. We know that the user will provide us with hours worked and hourly pay rate. Then our process, what we're doing with the input, is we're going to multiply those 2 values together. And what we're going to output, the gross pay to our user. We're going to display it on the screen. So this is just the same thing that we were talking about, just put into a diagram. All right. I say display a lot, and as I said, display is just a keyword to show any kind of output on the screen, project something on the screen. Now, another 2 terms that you need to be familiar with are sequence. Sequence is called just the way your program runs. So the way your program executes, the order of it is called the sequence. And string literal, it may be a little bit of a weird word, but string literal is just a sequence of characters. So just a word, a sentence, that's what we call a string in the coding world. As you can see here, these statements displayed Kate Austin, displayed 1234 Walnut Street, display Asheville, North Carolina 28899. These are all in order. So this will be printed first. As you can see here, Kate Austin is printed first. Then this is the second one that's going to be executed, 1234 Walnut Street. And this is the third and the last one statement that's going to execute, Asheville, North Carolina. And the way that these sentences are executed, that is a sequence. So they are executed in a sequence, in an order. So that's what it's meant by sequence. Input, as I mentioned before, input is just the keyword that we use to get any type of data from the user. And as I said, they're usually stored in variables. As you can see here, this is also pseudocode right here, pseudocode. We're displaying what is your age. This is our output. What is your age? Then the user will enter some sort of number. In this case, it's 24. However, you see that here we have input age. So that 24 that the user enters for us is going to be stored in the variable called age. So this is all that variables do. They just store information for us. And then we're just going to display, here's the value that you entered, and then we're going to display whatever they entered because we already have it stored. So these are variables, age and age, these are what we call variables. All right, let's see. Sometimes different programming languages will have different rules for naming your variables. And it just depends on the language that you're using. But overall, there are some rules that are they apply to every single programming language. So usually it's one word. You do not use any spaces when you're naming your variables. If you want to use a space, if you want to separate your words, you can use an underscore. So for example, if you wanted to name gross pay, your variable, you would put gross underscore pay, right? Or you could just use it as one word, gross pay without the underscore. That is also acceptable. No punctuation characters, so no commas, no periods, no colons, no semicolons, none of that. And generally, the first character cannot be a number. So if you want to put a number, you should put it at the end of your variable. And the main thing is that you should be naming your variables based on what they're storing. So if you have, for example, if you want to store user's age, you wouldn't store that variable you wouldn't store that data in the variable called name, right? Because that would not make sense. You would create an age variable to store the age of the user. The same way, if you wanted to get user's name, you would store it in the variable called name. So whenever you're working with variables, just make sure that they indicate what the data that is being stored in them. Just basic rules, basic rules for variable naming. Now, variable assignment, this is a little bit of different thing. So right here, you can see that we are setting dollars to equal 275. And this whole statement right here is what we call a variable assignment, because before what we saw is that our variables were assigned to values that the user inputted, right? Remember, input age, input gross pay, input hours worked, that all came from the user. However, we can also create variables that do not have to do anything with the user. In this case, we're setting dollars to equal 275, and this is what we call variable assignment. And then we're going to display I have whatever is stored in a variable dollars, in this case it's 275, in my account. As you can see here, this is the sentence right here. I have 275 in my account. And then we are also setting dollars after that. We're setting dollars to 99.95 and we're printing display, but now I have whatever is stored in dollars, which is 99.95 in my account. And you can see it right here, that sentence that we just coded right here. All right, all of the calculations in all of the programming languages are done using your basic math operators. And those expressions, again, they're all stored in variables. And I know you hear variables a lot, but this is just a part of coding experience, and everything is stored in variables. That's just one thing that you need to know. And the symbols are the same as in your algebra, basically, most of them. The plus sign is addition, the minus sign is subtraction, the star is multiplication, the slash is division, and then I'll focus on mod in a little bit because it's a little bit of a different function that you are not familiar with yet. And the arrow looking thing is an exponent. So you're going to raise a number to some certain power. So these are all the symbols that you should be familiar with right here, but I'm sure you've seen them before. It's nothing new to you. Now, whenever we declare a variable, we have to include the variable's name, and some languages will also need you to declare a variable's data type. And what data type is just you specifying what the user is going to enter. If they're going to enter a number, in the coding world, it's called integer. So that's what we call the whole numbers, integer. If the user is going to enter a decimal number, that's what we call a real. And that's just something that you have to memorize. There's no other way around it. It's just part of the vocab. And then any series of characters, which just stands for words, sentences, that is called a string. So 3 data types that you need to be familiar with. Integer stores whole numbers. Real stores decimal numbers. String stores any words or sentences. All right, let's move on. All right, another thing, if you want to have a variable that will never be changed during the execution of your program, that is called a named constant. And constant, you can kind of, based by the name, you can kind of tell that it's going to stay there forever because of the word constant. But a name constant is just a variable that will never be changed. So for example, in this case, we have a constant that is a data type of a real, and real stands for a decimal number of interest rate, and that is 0.069. But for example, if you need to make some calculations that deal with taxes, for example, we know that taxes never change, right? The percentage of federal or state tax, it doesn't ever change. So that's where you would use a constant. You would create a variable that will never change. All right, another thing that you can do is hand trace a program whenever you create your program and you're doing some, you have a question?
Oh, no, ma'am, good. I'm listening.
Okay. Hand tracing is just a process for locating any errors that your program has. But in this case, hand tracing is a kind of a old age process. We don't do that anymore. There are programs that do this for us if we need to do debugging of our code. However, it's just important for you to know that this thing exists. And what hand tracing is, you're just going to create a chart with columns for each variable. In this case, we have 4 variables, as you can see right here: test1, test2, test3, and average. And then we created a chart with them: test1, test2, test3, and average right here. But what we're doing is we're just tracing what each variable represents at each line of our code. So that's all it does. And then we're checking if there are any errors within our code, if our variables are doing something weird. But as I told you before, we don't do that anymore. It's kind of old practice, but that's a thing. That's a thing that exists. Now, when it comes to documenting your program, we have 2 different ways to document your program. The first one is external documentation, and the second one is internal documentation. The only difference is that literally in the name. So external is going to describe your program to your customer or to your user. So anybody who is not working on your program, they're going to look at the external documentation. However, internal documentation is the comments that you put inside of our program, inside of your code, that explain what that code is doing. Since when you go into the industry, you will not be the only person working on the code, right? You will be a part of the team, probably 5 to 6 people, a group of people that are going to work on the same task. And that is very important. The documentation is very important when you're working in a large group of people, because if all of you were doing just your own thing within the same piece of code, nobody would know what's happening, right? It would be chaos. So this is where internal documentation comes in. And this is with the help of comments, you can document your program really well. All right, now let's talk about designing our program. Now, in this example, we have a program that needs to calculate the batting average for any player. And we are giving a formula: batting average equals hits divided by the times that that player was at bat. Now, let's determine what we need for each phase of our program. So the questions that you usually have to ask yourself before you create any program: so what is going to be my input? What do I need to do with that input? What is going to be our output? Now, let's work on this together. So what would we have to read as input? What would we have to ask the user for based on the formula that we have right here? Anybody?
How many hits?
Yes.
The number of hits.
Yes. And
how many times they was at bat.
Yeah, great. Okay, so we need to figure out the number of hits and the number of times they were at bat. Then what do we need to do with that input? What do we need to do with those numbers?
And we're going to divide them.
Exactly. Exactly. So we need to calculate, make our calculations. And the last thing, what are we going to display for the user to see?
The batting average.
Perfect. Great. So we figured out, we covered our bases, no pun intended. But this is what we have to do. Basically, we just went through it. We're going to receive the input, the number of hits, the number of times at bat. Then we're going to calculate the batting average by dividing the number of hits by the number of the times at bat. And then we're just going to display the batting average. And let me show you what that's going to look like in pseudocode. As you can see here, we're creating our variables: hits, at bat, batting average. And then after that, we're going to display, this is where we're going to ask the user for input, actually, input of hits, input at bat, and then we're going to calculate. This is the internal process. We're calculating our batting average right here. And then the last step is we're going to display the player's batting average is whatever the calculations show us. So in this case, this is the output. This is what's going to be shown to the user right here. This is your code. So this would be your code, but in gray, this is what's going to be shown to the user. So enter the player's number of hits, the user would enter, in this case, 150, enter the player's number of times at bat, in this case, it's 500, and then we do some calculations behind the scenes, and we display that that player's batting average is 0.3. This is the flow chart for that same program that we just designed. And as you can see, the oval thingy is the start, the oval thingy, the end. Then these are our connectors, A, and then this is the internal process, the declaration of all of our variables that we would use. These are the declarations of those. Then these are the output, the parallelogram output, displaying the player's number of hits, then getting that input from the user, and the same thing, numbers at bat, getting that number from the user. And this is another rectangle internal process. We are calculating the actual batting average right here. And then after that, we're just displaying our last piece of code. We're displaying what the batting average actually is. So a little summary: input, we need to determine what data we need for input and choose the certain variables where we want to store that input, choose the names for those variables. Then process, the second step, determine what calculations you need to perform, and choose the variables where you want to store those calculations. And then the output, the last step, print the results of those calculations and show them to the user.
I have a question.
Yeah.
On the chart, where where the oval and the rectangle, yes, that. So would the oval, would that be considered the problem to be solved? The rectangle is the whatever the angle.
Parallelogram.
What is it?
It's parallelogram.
Parallelogram.
Okay. The parallelogram, that would be the information that was collected to solve the problem, and the rectangle is going to be the solution.
Yeah, basically, just think of it as a little bit differently. So the parallelogram, these things right here, stand for either you displaying something to the user. It doesn't have to be the solution. It doesn't have to be anything. It just have to be something that you're printing out, displaying to your screen. And at the same time, parallelogram also stands for user giving you some sort of input. So if user, for example, types something on the keyboard that their program asks them to do, that's what's called input. And for all of the actual rectangles, that's just the behind the scene processes. So anything that happens behind the scenes the user doesn't see, that is what's in the rectangle. So anything that the user cannot see, basically. Just the easier way to look at it.
Okay.
And then the ovals are literally, they just indicate where your program starts and where your programs end. That's all they do.
Okay.
All right, that's all I had for today. Let me stop the recording.